We've gotten to know a little bit about what it's like to work with, what it's like to be faculty, right, and what we do on a daily basis, and what it could be like to be part of that experience, and how you should approach faculty based on that perspective and some of their motivations. Now let's talk about much more in the weeds about what you could be doing as part of a faculty member's research and what that's like. So, we talked about the different research products, but you may be saying, okay, you held up a book, like I saw some graphs, like how did we get there, right? So how we got here is in two parts, right? There's the what are we actually doing? And then there's who's involved. And the who's involved also signals to you, again, what that organizational structure looks like and where you see yourself fitting and where you could wind up as part of an undergraduate research experience with a faculty member. So what? There is, in the research process, right, if we think about just doing a general study in education policy, we have a policy question. We have a research question. Does a particular truancy intervention policy actually encourage, better attendance in a high school, right? Or does this kind of technology math intervention actually increase, both technology proficiency in elementary math classrooms, but also, better differentiate the content. We see learning gains across, right? We have lots of different questions. And some of the questions have been asked before and they're in different policy contexts, and some of them have never been asked before. But then, once we establish what we're interested in, what our question is, we then begin to collect data if the data doesn't already exist, and we analyze the data. And that is largely what I think to be the longest part of the process, right? So if you think about qualitative education policy research, that could be interviewing stakeholders, right, at like the Texas Computer Science Association, if you're interested in computer science curriculum and learning standards. It could be interviewing teachers, adopting and implementing the computer science in their classrooms. Quantitatively, it could be leveraging like big data, the state's longitudinal data system, data that's provided to you by a school district. I joke all the time, sometimes data can seem like it's come to you in the form of a floppy disk, right? And hidden in someone's basement, and you get it, and it's like all the cells are in different columns, and like, oh my gosh, like this variable's named this thing in one year and this name in another year. A lot of the cleaning and collection is part of both the skill development and what you would learn as part of it, and is transferable skills, by the way, certainly to other industries. And then it's also going to take the most time. And that's where we need a lot of the support. And then there's the writing, which also takes a long time, but not as much time, in my opinion, as data collection and analysis, at least in education policy. And then we submit it off to our peers. I mentioned the whole peer review process, getting reviewed from other researchers, and that takes technically that takes the longest time most of the time, because it can be under review for 6 months, et cetera, and then there's publication, right? But let's not fixate on those last two, even though that's what gets your name out there and is ultimately the kind of currency we're seeking. Let's talk about who's involved with each of these processes, right? And where the skills start to develop. So you're signing up, ideally, to work with a professor, right? A faculty member who may or may not have graduate students. One thing not in that graph is they may have a postdoc, right? Someone who has their PhD but isn't faculty. But usually graduate students and then undergraduate students, right? Oftentimes graduate students are involved in the mentoring of the undergraduate students, which is fantastic. It's their kind of early opportunity to learn what it would be like to mentoring future graduate students for themselves, but also engaging undergraduate students. And so this is generally the setup on who is involved. And this is, at least for me, my setup and how I structure my mentoring opportunities in undergraduate research. So I have my 8 or 9 graduate students that I mentor and work with. And then I give slightly less time to undergraduate students, but I give direct face time to undergraduate students, and they get opportunity to be mentored by other graduate students who are slightly more advanced than they are, but I think can be a really nice bridge between someone like me who has not been in an undergraduate 4-year institution in X number of years, and maybe a graduate student who is more recently familiar with that process. So you think about, oh, I have questions about this National Science Foundation fellowship that I'm eligible for. Have you seen this? Have you applied for this? Like, what does a CV look like for an undergraduate researcher, right? those students may be really helpful as part of that professional development process. And so now getting back to combining the what and the who, where could you wind up, right? And I'm mostly going to focus on the quantitative education policy research that I do, but I'll try to give a shout out to some of the qualitative pieces too. So starting with data cleaning and analysis, right? Largely what undergraduate students who are interested in learning more coding or data management or even quantitative methods, they start out with preparing data, right? So I get data very often from school districts that we're involved with program evaluations on, or just partners that we have, or there's even national data sets that still come to you pretty unclean, and you need to be involved with managing that. And that comes with a lot of practical skills. It comes with learning a statistical syntax like programming software. That may not be exactly where you wind up if you don't, pursue, let's say, Stata, right? We talked about that in the second workshop. But Stata is very similar to R's programming language, right? And in general, it's the same thing when you are learning, like an international language. Once you've learned one, it is much easier to learn a second one or a third one, right? And so that is part of what goes into cleaning the data. I think it's the best kind of exposure to something like coding and thinking about like what you could wind up doing at a tech company or et cetera, because you have a goal, right? I have to clean this data. I'm being mentored to clean this data in a particular way. I need to convert, the yeses to ones, the nos to zeros, and you get all the tools to do that as part of an undergraduate research experience with me and many other education policy faculty members. And then this is where we start to get into a little bit fun of the methods, right? I may ask you once you're done cleaning a data set to check basic descriptive statistics to see if you've cleaned it right? And so just seeing, I have 90% of the data missing on, let's say, a student's free and reduced price lunch status, right? Well, that would signal, there's either a big flaw in the data we received, or maybe there's some error in your code and we can go back and troubleshoot where that would be, right? Other types of data cleaning and analysis on the quantitative side, you could be compiling supplemental data information that's related to a project, right? And so I give this example, I think, in a future slide, but I've asked my undergraduate students to go out and compile course roster data, right? And put prefixes in one column in an Excel sheet, the numbers in another column, the year, right, that we're talking about, and anything that I could use to merge that data with something else I'm working on, right? Or analyze that data myself. So that's another type of, tangible thing that you could be asked to do as part of that. So that's where a lot of the coding skill comes in. And again, this is why I kind of say, don't count yourself out just because you've never opened a statistical or syntactic software, because you have a goal as part of your undergraduate research experience, and you have the means to get there. Now, other things you could be asked to do is lots of reading and writing, right? So I think probably one of the most common forms of undergraduate research that faculty start with, I think, is asking you to do like an annotated bibliography or like a literature review, reading previous research, right? I find that like really boring myself, so I don't try to have my undergraduate students do that. But that could be something that if you're interested in doing, like you've never read journal articles, like that would be a great task, right? Because just because I find them boring to read doesn't mean you do, right? And you could learn a bit more. And maybe, let's say you're not from the education policy discipline, you're from sociology, and you read some sociological perspectives on education, maybe some especially qualitative pieces, but you're wanting that same perspective but in the quantitative piece. And so you may be part of a lit review team that's looking at a different way of looking at the same topic, but using a different kind of suite of methods. And then another thing you could be asked to do is to do something like put together like a memo of your analysis, right? So if you think about like you spent all this time cleaning and doing basic descriptive statistics, you may be asked to like write all this up in memos, right? That could be really helpful for me to see what you've done, right? And giving me basic stats, writing up kind of like where we go next in the project, right? There's different ways that your writing skills also start to hone in and develop, and they bridge, and I think it's a really nice connection between the data and the skill development piece with also how do we present this for a variety of audiences, right? So I've had students in the past put together memos, much less extensive than that, but much more like open face or people facing it, like a school district, right? So summarizing data in a very accessible way. And so that's also a unique skill you get to develop, and I think it plays into some of your writing skills as well. And then occasionally, as I've mentioned, writing manuscripts themselves can be part of the process. And that is really exciting, right? It's exciting to think about yourself having a name on a paper. And so I've had undergraduate students co-author with me and write different working papers. So that could be something that you are asked to do as well. So I've kind of incorporated several of these different examples as we've been talking, but some other examples that have come from my experience working with undergraduates here at Tech is compiling course roster information. I gave that example. But also I've asked a student to code this publicly available data set called the High School Longitudinal Study and asked him to run advanced quantitative methods that he learned in professional development workshops with me in my lab, with other graduate students, looking at whether having a same race and ethnicity teacher, so a Latinx student having a Latinx math teacher, a Black student having a Black math teacher, links to advanced math course taking for that student, right? So kind of signaling importance around teacher diversity and supporting students of color in STEM course taking. I've had undergraduate student scrape tweets because that's something I didn't know how to do. And this particular undergraduate student came from computer science and math. And so he knew how to do this, I did not. And I was like, can you do this? And he was like, yes, I can do this. And so this is another way of thinking about like the potential symbiotic relationship you can have in an undergraduate research experience with a faculty member. I've asked many students, graduate students, undergraduate students, clean, messy data sets. That's like my go-to, I think, at this point. So it's helpful for learning code. It's helpful for, just mindless. Sometimes it's mindless, I think, like coding and just trying to see if something merges and whatnot. So writing sections of manuscripts, they all have different sections. So assigning a student to work on the discussion section or the data section is how I've engaged students in the past. And then finally, I'm happy that I've had undergraduate students present at national conferences. So again, it depends on the faculty member you're working with, the graduate students, the projects, the field. But in education policy, we go to conferences all the time. We like to talk to people. We like to get our work out there. And so this is something else that my undergraduates have been part of in presenting. I think the record is one student presented in front of what had to be like 100, 150 people, like all fancy people. So I thought that was pretty cool. Okay, and then cool products as a result, right? So I like to focus on like abstract stuff, as I encourage you to do at the beginning, but also practical measurable things that can come out of an undergraduate research experience in ed policy. So think CV, job applications, and more, right? So I've had 2 working papers come out with undergraduate co-authors, 2 conference presentations, multiple kind of local university presentations at TRU's Undergraduate Research Conference. And then I'm always happy to provide a very strong letter of recommendation for graduate school, jobs, and fellowships. And I know, especially at a big institution, it can be really difficult to navigate that conversation with a faculty member and get that letter of support that really attests to your skills. And in a more and more competitive job market, having a letter from a faculty mentor in an undergraduate research experience, to me, has the most potential, I think, to get you where you want to go. Because that mentoring is beyond class. It's beyond, oh, I've graded their paper, or I've seen their essay, right? I've actually met with them, like we've talked about projects that we're both interested in. So